Hello, everyone, and welcome back as we continue our adventure through systems of equations. In video 4 here, we're going to be looking at solving a linear system with substitution. It's going to be the second example where we use substitution. So here we have a new system, our blue equation, negative 2x plus 6y equals 5, and our red equation, negative 4x plus 12y equals 16. Now, again, first step, we need to solve for one of our four variables, either the blue x, blue y, or red x, or red y. Now, in this example, you can see that none of the variables have a coefficient of 1. So what we're going to have to do is decide, hey, what variable can I solve for that's not going to give me any fractions. So what I like to do is I'll just go through and I'll take a look at each of the variables. So for this one, the first variable x, I see that the coefficient is negative 2. And what I'll do is I'll go through the rest of the equation and ask myself if the other numbers can be divided by negative 2. So can 6 be divided by negative 2 evenly? Yes, okay, good so far. Can 5 be divided by negative 2 evenly? No, it cannot. So I know I can't solve for the blue x without getting fractions. So maybe I'm going to have fractions. We only know once we check all four variables. So the next one I'll check out is my blue y. In this case, the blue y has a coefficient of a positive 6. So I'll ask myself, can negative 2 be divided by 6 evenly? No, it cannot. So I don't even need to check the 5 because I know right off the bat I'm going to get fractions if I solve for the blue y. So again, just go through the next one. Next one's going to be red x. So coefficient on red x is negative 4. Can 12 be divided by negative 4 evenly? Yes, it can. Can 16 be divided by negative 4 evenly? Yes, it can. So it would make sense to solve for the red x. You can solve for any of them, but the red x so far is the only one that wouldn't have fractions in that process. I could check the y just to see what's up. In this case, the red y has a 12 as a coefficient. Negative 4 cannot be divided by 12 evenly. So it looks like the only one that would avoid fractions in this case is that red x, which happens to be the one from example 1, but that's just a coincidence. All right, so let's go ahead and solve for the red x. So I'm going to rewrite my equation, negative 4x plus 12y equals 16. And we're going to solve for the red x. So I'll focus in on this equation here. I am going to subtract 12y on both sides because I want to get the x by itself. So let me get rid of that y term. That leaves me with negative 4x equals 16 minus 12y. On the left side, the 12y and the minus 12y turn to 0 and leave me with just the negative 4x. On the right side, they're not like terms, so I can't combine them. 16 minus 12y. I could have also written negative 12y plus 16, but that's really just up to you. And then, of course, I want to get 1x, not negative 4x's. So I'm going to divide everything by negative 4. And I have to make sure to divide every term by negative 4, or else it will not be correct. So on the left side, negative 4x divided by negative 4 is 1x, or just x. Then 16 divided by negative 4 is negative 4. And then negative 12y divided by negative 4 is plus 3y. So I've go ahead and I've solved for x. I've gotten x by itself for that red equation. Now, whatever equation I choose to solve for in step 1, I cannot substitute that back into the same equation or it will not work. So make sure that whatever equation you use in step 1, you use the other equation in step U. So I use the red to solve for x. I'm now going to use blue to plug that x in. So again, I like to rewrite the equation. The more steps you write, while it may be more work, it leads to less mistakes. So you want to try to write as much as possible. All right, so I'm going to substitute in my x. So anywhere I see x, I'm going to write the equivalent expression, which is negative 4y. I'm sorry, negative 4 plus 3y. All right, so I'm going to take the expression from my first step and replace the x in the other equation with that expression. From here, I'm going to want to solve for y. All right, so the first thing I would have to do is distribute that negative 2. Negative 2 times negative 4 is a positive 8. Negative 2 times 3y is minus 6y. And then plus 6y equals 5. Now I want to combine like terms, and maybe some of you see it, maybe not, but right here, minus 6y plus 6y. So if I have minus 6y's plus 6y's, I get 0. All right, I'm going to have 0. So basically, that's just going to disappear. Right? They turn to 0y, which is just 0. And I'm left with 8 equals 5. Now, when you get either no solutions or infinitely many solutions as your answer, the variables are going to cancel each other out at some point. We got rid of the x by plugging in negative 4 plus 3y, but then the y's canceled each other out. So when the variables disappear and you're left with just numbers, something equals something, that's when it's either no or infinitely many solutions. And the way you know which one is which is whether or not this is actually true. Does 8 equal 5? And the answer is no, 8 does not equal 5. So in this case, it's no solutions. Right? If it was two things that were equal to each other, it would be infinitely many solutions.